Alright. Okay. Hello everyone, welcome back to another lecture today. I forgot my wife is no longer using my chiddly dare. My jizzes scare. My jizzy chair. Okay, we're going to continue on from where we last left off. Again, thank you guys for tuning in. I appreciate whoever comes and joins in on these lessons. This is going to be what helps us progress into the future of programming. And I'm going to be doing a project soon, a pretty big one actually. Alright, let's go ahead and open up our terminal and then Google. Now I know these lectures or these pretty much just me studying and you guys watching. I know that seems kind of boring. I could probably make actual just short videos, but the whole process is there for me to see and look back at. That's what I use it for. And hopefully those of you that join along with me can do the same thing. Look back at everything and learn from it. Alright, let's go back. So there's a lot that goes into the CLI. Okay. This one is called Pipes and Filters. How can I combine existing commands to do new things? Objectives. Redirect a command's output to a file. Construct command pipelines with 2 or more stages. Explain what usually happens if a program or pipeline isn't given any input to process. Explain the advantage of linking commands with pipes and filters. So now that we know a few basic commands, we can finally look at the shell's most powerful feature, the ease with which it lets us combine existing programs in new ways. We'll start with the directory, shell, lesson data, exercise data, and proteins. So let's go ahead and go to there. So we'll go desktop, shell data, exercise, proteins. All right. That contains 6 files describing some simple organic molecules. The .pdb extensions indicate that these files are in protein data bank format, a simple text format that specifies the type and position of each atom in the molecule. So, ls proteins. Oh, it's because we're already in there. Okay. So there we go. We get all those files, the 6 files. Let's go into that directory with cd and run an example command, wc cubane.pdb. Okay, so we're gonna cd. Okay, we're already in proteins, and then we're gonna do wc cubane.pdb. So 20, 156, 1158, cubane.db. wc is the word count command. It counts the number of lines, words, and characters in the file, from left to right in that order. So lines, words, and characters. So that's 20 lines, 156 characters. 156 words, and 1158 characters. So line, words, characters. If we run the command wc asterisk.pdb. The asterisk in asterisk.pdb matches 0 or more characters. So the shell turns asterisk.pdb into a list of all .pdb files in the current directory. So let's go ahead and run that. wc asterisk.pdb. So anything that begins with with anything and ends in pdb. So it gives us a list of each document and their total. Note that wc asterisk.pdb shows the total number of all lines in the last line of the output. If we run wc-l instead of just wc, the output shows only the number of lines per file. So wc-l apostrophe. So we want to look at just lines per file. So we're going to word count lines only for all files that end in pdb. Okay. There we go, and it gave us 107 total. The -m and -w options can also be used with wc command to show only the number of characters or number of words in the line.
Okay, it's fine.
There we go, so we can go wc -m asterisk.pdb. Boom, total of lines, or no, total of okay, so M is characters and W would be words. So WC, word count of words in all files that end in PDB. So that's number of words. L is number of lines. M is number of characters. What happens if a command is supposed to process a file, but we don't give it a file name? For example, what if we type, but don't type? So what if we type wc-l, but we don't type the asterisk.pdb or anything else after the command? Since it doesn't have any file names, wc assumes it is supposed to process input given at the command prompt. So it just sits there and waits for us to give it some data interactively from the outside. Though all we see is it sitting there. The command doesn't appear to do anything. If you make this kind of mistake, you can escape out of this state by holding down the control key and typing the letter C once and letting go of the control key. So let's try that. So wc-l and then control C. There we go. So it got us out of that state. So, but if we did that, right, and we waited and we did, would that do anything or no? No? Okay. Okay, well, that's fine. Capturing output from commands. Which of these files contains the fewest lines? It is an easy question to answer when there are only 6 files. What if there are 6,000? Our first step toward a solution is to run the command. So wc-l asterisk.pdb greater than lengths.text. So word count so -L does lines, right? Okay, so anyway, so word count on the number of lines on all files that end in PDB with lengths greater than, so greater than lengths.txt. The greater than symbol tells the shell to redirect the command's output to a file instead of printing it to the screen. Okay, so print to file there. Okay. This is why there is no screen output. Everything that WC would have printed has gone into the file lengths.txt instead. The shell will create the file if it doesn't exist. If the file exists, it will be silently overwritten, which may lead to data loss and thus requires some caution. ls lengths.txt confirms that the file exists. Let's try it real quick. ls lengths. Okay, anyway, that's I guess after we run the command. So L, all files in PDB, put to a text file called lengths.txt. And then if we check for a lengths now, it actually gives us a text file now. Now we can send the content of lengths.txt to the screen using cat lengths.txt. The cat command gets its name from concatenate. So we're going to concat. So cat concatenate. Join together, and it prints the contents of files one after another. There's only one file in this case, so cat just shows us what it contains. So concatenate file. Join together. Okay, so we're gonna go ahead and do cat lengths.txt, and boom, that's our output. So we had sent, and actually I want to go open this up just to kind of see proteins lengths.txt, and why did it do that? Oh, okay, gotcha. Okay, well, let's actually close this. Pretty cool. I like this Linux system. It's actually pretty cool. Okay, so when we did this command here, word count of all lines. Okay, word count of lines of all files that end in .pdb, and what do they call that? And redirect it to a text file called lengths. So word count lines of all files ending in PDB, and redirect it to a file. Redirect command output file So it just means that we're going to create a new file with it. Okay. And then we put all the information, which is the length of the number of lines in each of those files, and it puts it in a file for us, and then we concatenate the file and make it show. We'll continue to use cat in this lesson for convenience and consistency, but it has the disadvantage that it always dumps the whole file onto your screen. More useful in practice is the command less, which you use with less.links. Less.links.txt. This displays a screen full of the file and then stops. You can go forward one screen by pressing spacebar or back one screen by pressing B. Okay, so we can do a less.links.txt. Okay, that's cool. Filtering output. Next, we'll use the sort command to sort the contents of the links.txt file. But first, we'll use an exercise to learn a little about the sort command. What does sort-n do? The file shell lesson data exercise data numbers.txt contains the following lines: 10, 2, 19, 22, 6. We run sort on this file. The output is 10, 19, 2, 22, 6. We run sort-n on the same file and we get this. So sort would sort it alphabetically, I'm assuming, and then sort-n would sort it by number from lowest to greatest. There we go. So -n specifies numerical rather than alphanumerical. Sorry guys. Okay. So I was correct. We will use the -n option to specify that the sort is numerical instead of alphanumerical. This does not change the file. Instead, it sends the sorted result on the screen. So now what we're going to do is we're going to sort -n links text. Boom. Can we sort another file? What's in here? Cubane? Let's do sort -n Cubane. let's clear that. We're actually halfway. We can put the sorted list of lines in another temporary file called sorted lengths.txt by putting a redirect sorted lengths.txt after the command we just used. Just as we use, to put the output of WC into lengths.txt. Once we've done that, we can run another command called head to get the first few lines in sorted lengths.txt. Okay, so let's go ahead and we're going to sort it by number, length.txt, and we're going to redirect it to a file called sorted lengths.txt. Oops. Okay, sort -n lengths.txt sorted lengths.txt. Okay, boom. And then we're gonna head -n one sorted lengths.txt. Using the -n1 with head tells it that we only want the first line of the file. -n20 will get the first 20, and so on. Since sorted lengths contains the length of our file's order from least to greatest, the output of head must be the file with the fewest lines. Redirecting to the same file. It's a very bad idea to try redirecting the output of a command that operates on a file to the same file. For example, sort -n lengths.length to lengths.txt or lengths.txt. Anyway, doing something like this may give you incorrect results and or delete the contents of lengths.txt. What does double arrow mean? We have seen the use of the greater than symbol, but there is a similar operator, greater, which works slightly different. We'll learn about the differences between these two operators by printing some strings. We can use the echo command to print strings. So we're gonna echo the echo command prints text. Okay, so we're gonna now say echo hello to test file 1.txt. And echo hello redirect test file 2.txt. Try executing each command twice in a row and then examining the output files. So let's go ahead and ls. So I actually want to go and look. So hello and hello. Okay. Nothing happened. They both put the same output. In the first example, it's written in test file 1, but the file gets overwritten each time you run the command. We see from the second example, but appends the string to the file it already exists when we run it the second time. Okay, hold on. It did. So all it does. Okay. So the double arrow is appends file aka adds on, not overwrite. Okay, cool. So it doesn't overwrite the file, it just gotcha. We have already met the head command, which prints lines from the start of the file. Tail is similar, but prints lines from the end of the file instead. Consider the file animals.csv after these commands. Select the answer that corresponds to the file animals subset.csv. Okay, so head -n3 animal. Okay, I want to go look into this file real quick. Exercise data, animal counts. Okay, I see what you mean. Okay. I don't know, let's find out actually. Option 3 is correct. For option 1 to be correct, we would only run the head command. For option 4 to be correct, we would have to pipe the output of head into tail -n2 by doing head -n3. Let's hold on, I want to see something real quick. Let's do head -n3 animal. So it's going to show the top 3 tail -n2 animal, right? And sort into animal. What? Oh, whoops. Sort. There we go. So what I meant to put. So the top 3, which was those, and the bottom 2. And then when we run this command, it's actually going to create gotcha. So first what we'll do is create head -in the first 3 of animals, and we're going to redirect that file into an animals subset.csv. Animals subset.csv. Okay. And then so we should have animal subset CSV, right? And when we sort animals subset, so we just have those top 3, which is the top 3 of animals, right? Okay, so now we're going to tail, put the last 2 of animals, sorting by the number, the last 2 of animals, dot CVS, and we're going to append it onto animals subset. And so now when we sort by number on animals subset, now we just have those 5, the top 3 and the tailing 2. So far so good. So the first 3 lines and the last 2 lines. I don't really understand. I think I'm just too tired, but I don't really understand this one yet. So I'll come back to that later. But passing output to another command. How long have we been going for? We might actually call it here. Kind of tired. No, we can do one more piece right here. Okay, passing output to another command. In our example of finding the file with the fewest lines, we are using 2 intermediate files, links.txt and sorted. Okay, oh yeah, we need to move back. And we're gonna move into CD proteins. There you go. Alright. Passing output to another command. In our example of finding the file with the fewest lines, we are using 2 intermediate files, links.txt. Let's make sure we're in there. Links. Oh, did we delete? No, we didn't. But I'm sure we can delete those. Actually, no. Let's not do that. Okay, so we're in the right spot. To store output. So we're using links and sorted links to store output. This is a confusing way to work because even once you understand that WC, sort, and head do, those intermediate files make it hard to follow what's going on. We can make it easier to understand by running sort and head together. Okay, so that's how to run 2 commands. That's what we were looking at a minute ago. So we can sort in lengths, and the vertical bar between 2 commands is called a pipe. Vertical. This is a vertical line. And that is called a pipe. Okay. tells the shell that we want to use the output of the command on the left as the input to the command on the right. So whatever that outputs is going to be our input. This has removed the need for the sorted links.txt file. Okay. I want to see by number sorted lengths, right? Okay, so instead of actually, because okay. Gotcha. Nothing prevents us from chaining pipes consecutively. We can, for example, send the output of WC directly to sort, and then the resulting output to head. This removes the need for any intermediate files. We'll start by using a pipe to send the output of WC to sort. So WC, so word count. Did I write that one down? WC means word count. WC is word counter hyphen L is number of lines hyphen M is number of characters hyphen damn it was M L and W for words. Okay. And W is number of words. Okay. So now it wants us to do WC, so word count on number of lines of all files that end in .pdb, and we're also going to sort them by number. And it gives us the same output. Oh no, it doesn't. What was I thinking? So we did sort. Let's redo that again. So sort. Oh god damn it. Sort number length dot text and the head number 1, and then we're gonna word count line all files ending in .pdb, and we're gonna sort by number. We can then send the output through another pipe to head, so that the full pipeline becomes so. Word count, line, on all files ending in PDB. We're going to sort by number for head number and display head number 1. Boom. This is exactly like a mathematician nesting functions like log 3x and saying the log of 3x. In our case, the calculation is head of sort of line count of file that ends in PDB. The redirection and pipes used in the last few commands are illustrated below. So WC -L so this creates an output. This creates a file, or output in a file. This this command, so we output it and then sort it. We use the head and then we create an output. In our current directory, we want to find the 3 files which have the least number of lines. Which command listed below would work? So these are creating stuff, so we don't want to do that. So WC, so number of lines, file, sort numbers, least number of lines. So sort by number and head 3. This one, number 4. Option 4 is a solution. And just to test it out, WC L asterisk. So we're gonna word count line any file, sort by number, and the first 3. And those are the files with the least number of lines. Tool designed to work together. The idea of linking programs together is why Unix has been so successful. Instead of creating enormous programs that tried to do many different things, Unix programmers focus on creating lots of simple tools that each do one job well and that work well with each other. This programming model is called pipes and filters. We've already seen pipes. A filter is a program like WC or sort that transforms a stream of input into a stream of output. Almost all of the standard Unix tools can work this way, unless told to do otherwise. They read from standard input, do something with what they've read, and write to standard output. The key is that any program that reads lines of text from standard input and writes lines of text to standard output can be combined with every other program that behaves this way as well. You can and should write your programs this way so that you and other people can put those programs into pipes to multiply their power. So, using pipe commands and filters gives us more power. And just putting them together, pretty much. Anyway, excuse me. Pipe reading comprehension. A file called animal.csv in this folder contains the following data. 2012, some data, animal, number. What Text passes through each of the pipes and the final redirect in the pipeline below. Note: sort-r command sorts in reverse order. Okay. So we're gonna concat, which is, I believe it's gonna display the files, right? So, or display the information. So we're gonna cat that animals file head through number. So let's actually see how that works first. So cat animals, right? I might have spelled that wrong. Oh, in the wrong folder. Right, and then just to double check. Okay, let's kind of work with that. So cat animals dot csv head hyphen n5, right? Okay, so the top 5 and then the bottom 3, 2 3 4 5 1 2 3, it's going to be all of them, and then sort in reverse order equals final.text. So there's a total of 8 animals already, right? Let's just cat animals right, 1 2 3 4 5 6 7 8, yeah, 8. Okay, so when we put that head in 5, so the first 5, the last, the last 3, and then we're going to sort in reverse order and redirect it into a text file called final. And then when we look, we now have a final, and we can actually look at that. How come it only inputs 3? And let's see, so it only does 19, 2, and 7. So it does the first 3, the first 5, the last 3, sorts in reverse order. Okay. Okay, so we already knew what this does. Right? We did this one. Let's add tail to it. Okay, I get it now. Okay, so pretty much when we do that, what we did, right? So cat animals, right? Okay, total of 8, right? And then when we add a head to it, right? So it's just the first 5. And then when we add tail to it, it's the bottom 3 of the 5 that we pulled, and then we can do our final command, which sorts it in reverse order, right? So 19, 2, and 7. Why? Is it going by date as well? I don't think so. Okay. First 5, right? Oh. I messed up. Okay. Hold on. Okay, hold on. We gotta do that again. Okay. Bear with me. Right? Okay. We'll pull that one out. Then we'll add head in 5. And then we'll do it again. We'll add a tail in 3. Okay, so the first 5, the last 3, 7, 19, 2. And then we're going to add the last thing, which is sort in reverse order. But why? Okay, well. Unless it does go by date and then number, right? I mean, I got it. That's how it went. Okay, the head command extracts the first 5 lines from Anil. Then the last 3 lines are extracted from the previous 5. Using the tail command, with the sort R command, these 3 lines are sorted in reverse order, and finally, the output is redirected to a file called final.txt. The content of this file can be checked by executing cat final.txt. The file should contain the following lines. Yep. For the animal CSV from the previous exercise, consider the following command: cut -d, comma f to animals.csv. The cut command is used to remove or cut out certain sections of each line in the file, and cut expects the lines to be separated into columns by a tab character. A character used in this way is called a delimiter. In the example above, we use the -d option to specify the comma as our delimiter character. We also use the -f option to specify that we want to extract the second filled column. This gives the following output. Okay. So we want to cut. I want to see what -d is. Man, ls. We're going to search for -d. Okay. Anyway. So we're going to cut out. Okay, so what we do is we cut using a delimiter, and we're cutting out the commas, and then we're going to specify which column that we want, which is column 2, which contains the animals, and then from that file. Okay, so we will cut the commas and only look at boom. Excuse me. Very cool, very cool. The unique command filters out adjacent matching lines in a file. How could you extend this pipeline using unique and another command to find out what animals a file contains without any duplicates in their names? Cut D, comma, F2 animals dot CSV, sort in alphanumerical order, and use the unique code. What does unique command unique is a utility command on Unix. Plan 9 for Unix like operating system, which when fed a text file or send input, outputs the text file or text with adjacent identical lines collapsed to one unique file line of text. And how did we have it before? Let's see. Cut D, comma, F2 animals. Oh. Why is that? Oh, gotcha. So it eliminates the repetition. The file animals.csv contains 8 lines of data formatted as follows. The unique command has a -c option, which gives a count of the number of times a line occurs in its output. Assuming your current directory is a shell lesson data exercise animal counts. What command would you use to produce a table that shows the total count of each type of animal in the file? Okay, so we would do it's gonna be okay, so we're gonna cut, right, same thing that we did, but we're gonna do a count instead. But actually we're gonna sort count it. Okay, let's try it. Cut D, comma, F2 animal.csv, sort unique So deer, rabbit, raccoon, fox, and bear, total of 5. It's going to be the last one. So word count line of each unique animal, right? 5 different unique ones. And this is how many times that they're played, right? So that's 4 makes 8. It tells you how many times they're in there. But this tells us how many lines there are. So it's going to be number 5. What? Oh, total count to each animal type in each file. Okay, gotcha. Okay, that makes sense. 5 just shows how many animals there are listed in our file. Okay, gotcha. We're trying to see the numbers with them. How many times they're listed. So Nell's pipeline checking files. Actually, I think this is where we're going to end it for right now. We'll come back to this tomorrow. We'll remember Nell's pipeline checking files. So, yep, this is pretty cool. I hope you guys have been enjoying the journey so far. I know it's a long process, but we're going to get there. Thank you guys for tuning in. Those of you that do, I appreciate it. Those of you that don't, still appreciate you. All love around here, baby. Alright, y'all have a blessed one. Stay safe. Enjoy y'all's day. And happy coding. Peace out, Girl Scouts.